Hello, everyone, and welcome to Amplified, the podcast where we explore how technology is transforming industries and amplifying human potential. I'm your host, Ishaant Majumdar, a high school junior fascinated by how software, systems, and AI can solve real world problems at scale. Today, I'm excited to welcome Julia Tu, the Chief Technology Officer of RENKOM Technologies. Julia works at the intersection of enterprise software, scientific data systems, and AI enabled platforms. She has played a key role in building and deploying an electronic batch record system used by scientists at MENA to manage experiments end to end from from structured data capture and processing to visualization, documentation, workflow automation, all within a single integrated platform. In today's conversation, we'll explore how modern enterprise platforms are evolving, why data structures matter more than ever, and what it really takes to bring AI into complex real world scientific workflows. Julia, thank you so much for joining me on Amplified.
Yeah, of course. Thanks for having me.
Absolutely. Before we dive into platforms and AI, I'd love to start with your personal journey. You've worked closely with Mena and are now of course, the CTO of Renkom Technologies, where you work with building and deploying the enterprise systems. What originally drew you to working on infrastructure and systems rather than, the more isolated applications or tools?
Oh, like why I focus more on the data structure side of
Yeah.
things. Yeah, I guess in the context of enterprise systems, like your data structure is kind of everything. It's the foundation of your system, and it really helps to decide if your system is going to be like strong or stable down the line or like a real mess. So I really enjoy the aspect of system design and then also seeing what can be built on top of that, like all the automation and intelligence and different features that can result from that data structure.
Yeah, yeah, absolutely. And these, data structures, of course, are extremely important for like, the development of medication. You know more than I do, but it's really important for these things to be organized, of course. But with this, what are some of the biggest limitations of, the fragmented software stacks in scientific and enterprise environments?
Yeah, so first we can define fragmentation in this context of like scientific teams or enterprise systems.
Mhm.
So fragmentation refers to like the scattering of data across several different systems and
Right.
devices and accounts. So really a core characteristic of this like enterprise fragmentation is just broken data flows. And these broken data flows are a real problem because that creates a very weak foundation for building like automation and AI on down the line. Like I'm sure you recognize that there are actually a lot of really powerful AI processing tools and like automation tools out there,
Yeah.
but most companies cannot properly leverage them because they don't have the right data structure to do so. Their own data fragmentation issues are preventing them from really getting to leverage AI and automation. So the most important thing for building automation and AI is always a clear, unified, and well-structured data. And unfortunately, very few teams or companies can say that they have this.
Yeah, yeah, absolutely. In like these kind of contexts, the AI is really as good as its data, I guess you could say, and it's only going to perform as well as, what you're giving it in a lot of
Yeah.
these cases. Yeah. And then, of course, these are um, like huge applications and versus like point solutions. So why do these point solutions struggle as workflows and applications become more, complex as they, scale up and that kind of thing?
Yeah, so point systems, it's interesting. Like point systems are kind of like the cause of this fragmentation issue to begin with,
Mhm.
because
Yeah.
the problem is that a lot of companies built these point systems and they work really well, but only for like a very specific business function.
Mhm.
And the reality is that like a business, no matter how many like divisions and moving parts it has, it's still one integrated entity.
Absolutely.
And like workflows like naturally will cross teams and share the same data. So everything in a business is interconnected, but those point systems are not. Like they're not designed to be integrated with each other. So that's where there's a really big break in a company's software systems. In that point solutions can't support the entire operation because they're all fragmented.
Okay, I see. Yeah. And of course, you're working with electronic batch records, or I guess EBR,
Mhm.
right? Could you give us some background on what they are, just generally?
Yeah, so Well, our EBR system, it stands for electronic batch record. This is like a documentation system for scientists to like document all of their lab activities. um, like their experiments,
Yeah.
procedures, results, any samples that were derived, etc. So MENA's EBR system is a collaboration between RENKOM and MENA. So this is our specific version of EBR is a electronic lab notebook system, but also combines very strong data storage and processing capabilities. So you can imagine like an environment where scientists can register all of their experiments, procedures, and activities and results, and then run any of the needed like scientific data processing within that environment as well. So it's like a super unified custom built system that can really capture all of MENA's experimental activities. Um, yeah, and then with like I think like context is important here. So like um, this is a pretty advanced tool, I would say, in the current environment. I know you're still in high school, so I'm not sure if you've had this experience yet. But in like high school or college, you'll take some like lab classes, and you'll
Mhm.
probably have to maintain something
Yeah.
like a lab notebook,
Yeah.
like a physical notebook. And this is like a super archaic way of like documenting your experiment. And what's like really crazy is that a lot of like biotech companies and university research labs still
Mhm.
use this system. So like previously when I mentioned fragmentation in terms of like systems and accounts and devices, like your physical notebooks is like a whole different beast. So like if you can imagine like an entire scientific team having just like all their data on like 50 notebooks, like they're
Mhm.
never really going to be able to leverage any of the automation and AI that is really needed actually in the healthcare and biotech industries.
Yeah, yeah. I've worked a little bit with this kind of like working with medical data in a couple different contexts, but I've never worked directly really with like scientific medical data. What is the kind of information they're producing? What are the kind of experiments they're doing for some context?
Yeah, so Mena, and there's also another sister company involved called Metabulan. So Mena focuses on like manufacturing. So a batch
Mhm.
record for them is a little more simple. They're like manufacturing a certain product. So there's like a very set of procedures that they go through, and the scientists will enter the notebook and just knock items off. For Mena, a lot of the scientist entries are like pictures, like proving that they're like actually like making the um, manufacturing the item and like showing all the supplies they use and like measurements, etc. Because these things need to be like super audited. On Metabulin's side, so Metabulan is developing ultra stable insulin. So a lot of their data is more centered around like purifications,
Okay.
like trying to purify insulin and like maximize yields. So their data is a lot more oriented with like there's like concentration readings and chromatogram data.
So sorry, chronatomic dang, I can't.
Chromatogram.
Is that dealing with like time and that kind of thing?
Yeah. Let's see. I think a chromatogram is kind of it's like a laboratory technique, and it's kind of showing like the components of a mixture.
Okay.
So
Okay.
our chromatograms, they kind of look like a line chart, like you're trying to see over time, like if you're running a column trying to do a verification, like how much sample or what concentration of a sample is coming out at any different point in time.
Okay.
So yeah, that kind of more like that kind of data.
Okay. That makes a little bit more sense. Yeah. So of course that's going to lead to like because you're doing so much stuff, you're going to lead to so much like diverse work that you have.
Yeah.
And because you're structuring it, of course it's going to save up along like a lot of costs and a lot of headaches. But how does structuring data early on change, downstream analysis, visualization, automation, working with this data later on?
Yeah, so the data structure is like the foundation of your system, and it really defines the stability and capability of your system later on. So, a clean data structure makes it easy to run your downstream analysis, visualization, and automation because it'll be very clear to your users or your system to know exactly where to find data and where to like store outputs.
Okay.
So, it's just a very clean environment um, on which to build your system.
Yeah, yeah. It's personally saved me a lot of headaches when I've, of course, organized work like that. I've had to work with like a lot of like NOAA, which is like NASA's, subdivision for weather and that kind of thing. I'm extremely grateful because they give their data extremely cleanly, and it's huge amounts of weather data. While a lot of the if you're trying to get information for, like, let's say Frisco specifically, you're gonna have to work with like people's personal weather stations, which is like a lot more difficult because everybody has their own sensors, everybody has their own thing, which they kind of like combine together. So it definitely saves a lot of headaches, and of course, for a lot of the reasons you said. But when designing this, what challenges were most, let's say, underestimated when designing systems for like real scientific workflows for real, people working in the field?
Yeah, so I think one of the most like underestimated challenges is like learning how to run a design process while collaborating with end users on this resulting system. So I mentioned that Renkom and Mena have a really great partnership in that like Renkom builds custom software tools for Mena.
Mhm.
And you would think that this is just like a really clean and easy relationship, right? Like they tell us what to build and we just build it.
Yeah.
And that's like, I would say it's a very simplified way of looking at it because like, these scientists, they're not like system builders. They're not thinking in terms of data structure or best practices, or don't even really understand how like one small feature that they might request would impact a lot of downstream complexity.
Hmm.
And at Runcom, it's kind of interesting because our clients get like so excited when they learn like what the system could do for them because it's so like powerful and flexible. They're like, "Oh, can we add like a button here? And then if you click that button, it'll trigger all these other activities, and then we'll do like this big scan." So I think a big challenge of the job is also like knowing like when and how to say no. Like, no, that's not going to work, or like, yes, we can do that, but it needs to be in this way. And I think the reality is that like a lot of users have interesting insight, but they usually don't know like exactly what they need or how to get there. So I think you do need to like eliminate this concept of like the customer is always right in that sense. And I'll give kind of like a severe example, but like in 2007, when the iPhone came out,
Yeah.
like Steve Jobs and Apple actually got a lot of like blowback and criticism because the iPhone didn't have a physical keyboard. It had the touchscreen keyboard, and that was like the first of its kind to
Yeah.
have a touchscreen keyboard. And they got so much feedback like, there's no way that's gonna work, like, it's too hard to use, the keys are too small, etc. And apparently, Jobs allegedly applied with like, your thumbs will learn. So it's kind of just like a story of how the customer is not always right, and I think it can be hard to like reconcile with the fact that like you are building for the end user, but they sometimes don't even know what exactly they need. So it's just kind of hard to consider, like it's like hard to know when to consider a user's valuable insights, but like also know when and where you need to stand your ground as like a builder and a designer.
So you have to understand, both aspects. You have to understand the work that the scientists are doing themselves, but then also what you're doing yourself and knowing how to apply it. So you're kind of doing two things at once, almost, right?
Yeah, for sure. Yeah, there's a lot of information to digest, like from on your side, on the system building side, and then on the actual use cases. And then you need like the communication skills to like bridge those teams
Mhm.
together so they're all on the same page.
Absolutely, absolutely. And I think also with like the advent of AI, some people might be a misunderstanding what it really does and what it really is. And sometimes some people think maybe it's a, you know, one solution for all. But then a lot of people also underestimate some aspects of like the scale of like how much it can be convenient for you. So it's kind of like a weird mix of both, I guess you could say, in a lot of
Yeah,
cases. Yeah.
yeah, for sure.
And then, with this, right, with the work where you're doing it with for real scientists, workflows and that kind of thing, what does like, because you're applying AI to it, of course, what does AI ready infrastructure really mean in practice, and like just generally, what does it mean?
Yeah, so I think AI ready infrastructure just refers to any architecture that you can add like a layer of intelligence to. And
Mhm.
it's about making sure that your system's AI can like reliably find information, understand it, and then like perform activities of work across the system.
Yeah.
So I think Mena's EBR example is great because EBR at first, right, it was just the data structure, an interface where scientists can document their experiment and procedures.
Mhm.
But because that data was so clean and we had so much of it, it was very easy for us to develop an automated study report feature on top of that. So that would consolidate all of the scientists' like experiment, and then we can pass it to an AI model to generate the content for an automated study report at the end.
Okay.
Um, so,
So,
so yeah, it's just AI ready infrastructure is yeah, just architecture that you can add the intelligence.
yeah. So you're generating automatically generating these reports for the researchers and that kind of thing.
Yeah, it's cool. So once they finish their experiment, they'll click a button that says like it says AI with an arrow on it. But
Mhm.
when they click that, their experiment's information will be sent to GPT along with a pretty advanced like system prompt, and then a couple minutes later, they'll get the opportunity to download a full AI generated study report. So they don't have to write it themselves. It all comes out of their
Yeah,
VR.
that's very convenient. But I'm a little worried, especially with the work you're doing. How do you ensure that it's like um, the report you're generating is accurate? Because a lot of people would be scared. Oh, what if there's a hallucination and that kind of thing?
Yeah. So couple strategies we do. One is our prompt is like it's actually probably a lot longer than you would expect it to be. We add a lot of guardrails and
Yeah,
explanations to help guide the AI model to
absolutely.
produce
Yeah.
the right kind of output that we want. So, for example, there's like a whole section on like different definitions and what exactly we're trying to accomplish overall, and then like there's a template at the bottom, so AI knows how to structure the report and what sections we want. And then there's also been a lot of testing done. So,
Mhm.
we don't just release it
Yeah.
and have the scientists just start making reports. We tested quite extensively, and then once we were satisfied with a lot of the model's outputs, then we launched it to our scientific teams.
And I do testing, like I assume, with like human validation and that kind of thing.
Yeah,
Yeah. Okay. So, because I know that's how they do it with a lot of like, a lot of insurance companies are automating reports, and then like IMEs are being auto generated. And that I know they kind of have like a golden records system and like a human validation system. So I'd assume it'd be, the same. Um,
yeah. We mostly do human validation, but there's like a cool setup in which you can like pass the information to like multiple models
mm,
almost, and then
yeah.
how to describe it. It's like models can check each other. Like you
Yeah.
don't just utilize one model. So there's also another setup in which you can have multiple models checking each other, and then you can really optimize to find the best one for your study report at the end.
Absolutely. Yeah. Yeah. And then of course, like you can do validation with, I think, because I know some startup companies do this where they've generated the report and then like with, I don't know, like a mini LLM or something, and then or not mini LLM, like with Claude or something, and then they feed it to Gemini and say, what's the difference? Is it correct or not?
Mhm.
Um, why is like workflow design, like you said, how the AIs are checking each other and the validation kind of thing? How is that workflow design often more important than like the actual model selection in these real world AI systems?
Yeah, so I think workflow design matters more than models because the actual workflow design is what turns AI from just like providing answers into
Mhm.
providing like real outcomes.
Okay.
So the workflow design will define the steps and the inputs and the outputs that are needed to actually move work forward and like generate that productivity.
Mhm.
So the workflow design defines what gets done, and I think models are just like a tool to add some intelligence into the workflow. And I think what we're seeing with the models is that there's been a lot of like hype and a lot of advancement in the models in the
Yeah, of
past few years,
course.
but I
Yeah.
think we're kind of reaching a point where like they're kind of about as smart as you need it to be, and they're really like leveling out. I would say like a lot of the models in our use cases at least, they're
Mhm.
very interchangeable. Like I would say our automated study reports, like they're pretty advanced, but it's like every model out there, all the leading models out there can do it today. So I think models are like less of a differentiating factor now. It's really all about your design and your actual applications.
Absolutely. And like a couple, even now, like these models are changing every 6 months, right? Like even
Mhm.
month old information is sometimes outdated in terms of like things like benchmarks, of course. And with this, with like today's world, what's missing today that's preventing, a lot of these AIs from really having an actual transformative impact in biotech and healthcare?
Yeah, I think it just all comes back to the unified and integrated data structure. So I think, it's kind of unfortunate with like biotech and healthcare. They have so many different like point systems, as we
Hmm.
talked about earlier. And then also so much data is like not even like in the cloud. It's all like on random Excel spreadsheets or
Mhm.
stored on like actual instruments or even in those physical lab notebooks. So there's just they don't have the right system to store all their information, and they don't have the right like I don't think there's the right culture in biotech to really emphasize data
Hmm.
in a way that can be used later for real um,
Absolutely.
automation and AI.
Yeah. Funny thing, I was speaking with a professor at Case Western, and he was saying like a lot of these systems would have taken like a lot of the processing would have taken months, if it was like 20 years ago, because earlier the way they would take the data and the way they would do the analysis was usually by hand or like through these Excel spreadsheets or maybe even older version of that. But now a lot of these, like, let's say he was talking about a PhD student specifically, how a PhD student took only maybe like one day to do something that would have taken him an entire month, just 20 years earlier without this technology. So it's kind of crazy how this stuff has kind of developed.
Yeah,
And
technology plays a big factor. Like I think you have some experience with like coding, right? But even like the
yeah,
whole vibe coding thing, like
mhm,
people are building out like entire applications in hours,
yeah,
and it would have taken like probably even like months or years to do that before these AI models came out and were widely available. So
yeah,
yeah, crazy how fast technology moves now.
yeah. And a big part of that, I guess, too, was like the data, like getting access to the data, because we always had the ability to make these AI models. Like the idea itself isn't exactly new, but I
Hmm.
guess the data was kind of like the limiting factor for a lot of these, like I guess LLM models and all that kind of stuff.
Yeah, for sure. And then yeah, we kind of talk about this at RENKOM quite a bit, but like you know how ChatGPT came out like 3 years ago.
Yeah.
What's kind of sad is like the model of GPT has gotten like significantly smarter, but like the way in which we still interact with GPT is the same. Like we're all still on that chat interface, and that's
Hmm.
because we have no like integrated setup where we can like interact with GPT models from our like actual systems that we work on. Like our
Yeah.
scientific processing tools, etc. So
Yeah.
yeah, the data structure and unified systems part is a really big issue with AI
Yeah.
advancement.
And you were actually quite right. Like a lot of people are interacting with the same way. And specifically on like the scientists, how do you get the scientists to effectively adopt and, use EBR system in their, day-to-day work and experiments?
Yeah, so I think proper user adoption is like one of the hardest parts of like software deployment, like
Mhm.
getting a bunch of people to like be on the system and use it properly and really consider the software's role in their day-to-day work. And also like people don't change very easily. So
Sure.
like when you think about user usage, like
Yeah.
I think it's really important to hone in like on the real benefits that the system offers them. Cause like one, people don't change very easily, but like they're definitely not going to change their ways for a system that's like not working or that doesn't serve them better than like what they're currently or like previously using. So one tip is to just always like emphasize the benefits over and over again to really make them understand why it would be more beneficial for them to get on the new system. So with like deploying the EBR system at Meta, it's like kind of a big shift for a lot of scientists, right? If you're used to just writing your stuff down on a lab notebook and it can be like kind of sloppy and nobody's really looking for the data, it's a
Yeah.
big shift when you start asking people to document like all their activities, all their results online on the online notebook. So um, getting to them to do that is quite difficult, but it's when you really hone in on the benefits. Like, oh, you won't have to write your study report. Like, if you do this, you get to benefit from the automated study report down the line, and it'll be so much easier for you to present during meetings because you have your whole experiment right here, like ready to show everybody. Um, so I think really honing in on the benefits is really important in deployment. And two, it's really important to have your like super users. So at Runcom, super users are like your power users that are really good at the system and are champions of the system amongst their teams. So
Yeah.
it's different when like a manager is like hounding you to use a system or do things a certain way.
Mhm.
um, I don't think that hits as hard as like your peer and your colleague using a system really well and encouraging you to use it and showing you how to do it. It's like quite important to have your super users that can help champion the system amongst the actual teams that will be using the system.
Absolutely. And it definitely seems like not only difficult, but also very frustrating sometimes to get the people to use a system. So the concept of a super user is a little foreign to me. Like it makes sense in my head but I didn't know it was like something that people actually, really took into consideration when kind of developing these systems. Are these like super users people that I guess plant? I don't know if that's the right word, or is it just people that develop naturally?
Yeah, I guess it's kind of a mix of both. So I think yes, you do kind of plant them because you like sometimes you explicitly tell them like I would really appreciate if your part of your role moving forward is like really making sure that this software is well deployed amongst this team and that the whole team is using it well. But of course, like I guess the way in which you like pick these people, they have to have like very natural tendencies. Like usually they're very quick and can really understand like the value of software and technology in their role. They're usually like a great team player. They know how to talk to people and they want to communicate with others. So yeah.
Yeah, yeah. Communication is definitely a big thing with that, and especially with using these AI models. Um, and I think a lot of people like to have the same kind of sentiment where if their manager is kind of telling them, "Can you use this AI tool? Use this AI tool," they'll feel little bit frustrated because I think in some maybe a lot of industries it kind of feels useless to them,
Hmm.
like especially online. If you've seen the sentiment that like AI is kind of being in everything, and like I think it kind of makes sense because in a lot of cases, it's not used, but it should be used for something like the medical field a lot.
Yeah, I think yeah, they're these like super users. I guess they're kind of like the influencers on your team. They just trying to
Yeah,
influence everybody to use the system, and then generally like these social media influencers are like very likable and they really package things in a very desirable way. So there's that, and I think yeah, like once again, if it's your peer that's using the system in a certain way and you see how they're directly benefiting from using that system, I think you're just much more likely to follow along.
absolutely. Yeah. And I guess looking a little bit towards, the future, how do you see these how do you see enterprise and like a lot of these AI enabled softwares evolving over the next 3 to 5 years? Or maybe even longer than that.
Yeah, so it'll definitely evolve a lot and very quickly. Sometimes it's like it's so fast you don't even um, know where it's gonna end up in like 3 to 5 years. But I think right now, like how vibe coding is like huge.
Hmm.
So it's super popular. But what's interesting about vibe coding is that it's done on a very individual basis.
Oh,
So
yeah.
coders will like very independently vibe code, and then they will contribute those code outputs to their company or team or whatever. But of course, like it's not very efficient to have a bunch of people like independently vibe coding and independently writing their own prompts. So what I think will happen is that the vibe coding will be very like consolidated within organizations. I know
Mhm.
like right now, I think some people think vibe coding is really looked down upon, but I think businesses are going to really I guess leverage this concept of vibe coding, like using AI to write code moving forward. And I think these organizations will likely develop their own like library of prompts and templates to really help people, I guess, vibe code in a very like governed and standardized way.
Yeah, yeah, definitely, definitely. And I think it's already been implemented a little bit in like Git. If you look, they already have kind of like I believe, a framework for you to vibe code and then work with other people to kind of consolidate like its own LLM model in, I guess, GitHub.
Yeah.
I Yeah. What were you saying?
Oh, sorry. Yeah, I guess like side point, like sometimes with RenKom, like we develop these custom software tools. Sometimes I envision like imagine like an interface where you just
Mm,
like click like you just like basically fill out a form and then the
mm,
AI model on the back end will like take in all your inputs and all the like library of prompts and templates and then be able to output like perfect code for you. So I kind of envision like this concept of like click coding or like filling out a form to code will be much more common. Just like
yeah.
user makes their selections and then that like vibe coding or AI coding will happen on the back end and then on the front end the users will just get their like perfect code.
Yeah. I think it might even go further than that, where it might even just start like saying, "Do you need this piece of code?" before you even think, before even like to fill out the form and everything. It might even come to that point in like that kind of point in a couple years. And of course, you're in a big position yourself. CTO um, is like quite crazy for, especially at a company like Renkom doing having such an impact. For students, what advice can you give to students or early career engineers and programmers interested in building these complex scientific and like enterprise systems like these that are used,
Yeah, I think Jensen Huang of NVIDIA kind of talked about this in one of his interviews, but I guess like software engineers or like engineers, you shouldn't think of yourself as just like a code writer. Like you need to think of yourself as like a real problem solver, and the like core technology that you work on, whether it's like probably code, it's like code is just one of the tools that you have to solve problems. So
Mm.
always when you think about when you have like projects you work on, think of it more so from like the actual application side. What problems are we going to solve? What issues are we going to address? Rather than like focusing on like the really small nitty gritty pieces of technology.
Yeah,
And
that's a,
then
yeah. What were you
yeah,
saying?
sorry, go ahead.
No, I didn't have. I was just.
Yeah, and then like along with that, I think like like working on your project management and communication skills is really important.
Hmm.
I think moving forward, like I said previously, it's like less about how good of a coder you are.
Mm.
It's more so about like, do you really understand your users needs? Are you able to manage people and their expectations? And I know there's this like running stereotype of like the software engineer being like this really socially awkward and like
Yeah,
weird person, but I think it's kind of funny because this is an industry where it actually requires a lot of strong communication skills because the projects are usually so complex and there's so many stakeholders involved. So I think if you can be an engineer that's very people oriented, very strong communicator, you will be a lot more successful in the field.
absolutely. Yeah, and I actually say, what you said kind of put what I was thinking into words. Where, if you're a programmer, you don't really define yourself by a programmer, rather someone who just kind of solves problems. Like, a lot of like researchers in a lot of these fields have a background in software engineering, but are mainly creating impacts in, like, let's say, like agriculture or something, right? So their background may be programmer, but they're helping these kind of fields. This has been an incredibly insightful conversation. Thank you, Julia, for sharing how thoughtful system design, structured data, and integrated platforms can fundamentally change how science and enterprise operations work. Before you wrap up, is there anything you'd like to share to our listeners? Perhaps advice for aspiring builders, or where they can learn more about RENKOM Technologies?
Yeah, well, our website needs a little work, but we do have a website, renkom.com. And then a big item for me moving forward in the Bay Area is making more videos. So our Renkom YouTube channel will have a lot of new videos showing like core features and capabilities coming up soon.
Nice, nice. And I'll definitely put that on the screen if it's not there already.
Okay.
And to our audience, if you enjoyed this episode, please subscribe, share it with friends, and stay tuned for more conversations amplified. If you want to reach out, please email me at ishaantmajumdar@gmail.com. Thank you so much for joining us on this podcast, and thank you for listening.